Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor IARE, Hyderabad. So in previous video we had seen how the loads are acting on the aircraft, then function of a structural elements. We had seen that a structure of that elements. Okay, so in that we had seen which that ground loads, air loads, how those two types of loads are there. Right, ground loads, air loads. The ground loads was what? When that aircraft is in contact with the ground. So whatever the load is acting, that or during the taxiing, movement or towing. Okay, so whatever the load is acting at that time, that is called as ground load. The next we had seen what? Okay, the air load. So during the steady flight or during the maneuvering, okay, whatever the load experienced by the aircraft in the air, okay, while flying, those are called as the air load. So these two main types of loads are only there, right? Now based on that, the further they are divided into direct load, indirect load. Like direct load, aerodynamics load is there. Because of that, aerodynamics and hydrostatic is there. I already also discussed aerodynamics. We will not see here. Okay, so we had seen just whatever this one. So now in this video we will cover what function of a structural component and actually and airframe load. So load acting on airframe. Okay, so let's see first function of a structural component first. So aircraft are generally built up from the basic components of what? Wings, fuselage and tail unit. So these are the three main basic components of the aircraft. In that, so just see, this is the what? Tail unit, this is wing, and then this one is the what? Fuselage. So these three main things are there. In that, many things are there. Now, so just see first, wing provide what? Wing, main use of the wing is to generate the lift so that aircraft will go up. That this one, okay, that rear part, or you can see the tail unit, is mostly you can see that as the control surface. So what is that? So see, this is the vertical one. So vertical tail provide directional control. If suppose you want to move left or right, that can be done by this, the vertical one. Okay, horizontal tail countering the aircraft tendency to pitch in a vertical plane. So that move up, down based on this, that. So this will control for movement of up and down. Okay, so that's why this is generally called as the control surfaces, because with that we can control. Some control surfaces are on aircraft wings also, not only in the tail parts, but on the wings also is there. But in the wings, whatever the control surface is there, that, or you can say that is just to reduce the aerodynamic pressure, forces, speed. These things are there. So while flight, you can see in many places, or you can that during the landing, once the aircraft touches the ground, that time they just to completely open that aileron so that the drag will be more and hence lift will be less or thrust will be less. Why? Because drag is opposite acting to the thrust, right? So this is drag. If more drag will be there, means definitely what? This will be the lesser. So when thrust and drag will be equal, then there is no movement. So whatever the bigger one is there, according to that it will move. If thrust is bigger, then aircraft will move in forward direction. If drag is more, then forward, that aircraft will move in backward direction. Okay, so that you have to see in which direction it is there. So always thrust should be higher, and then not only higher, too higher compared to the drag, so that aircraft will move in the forward direction. Okay, so these are what? The components of that aircraft. Okay, so mainly three: wings, fuselage and tail units. Okay, so now the function of a structural component continue. So there are various in particular aircraft. There are variation in particular aircraft. So based on that aircraft, whatever the type is there, according to that, they will have their structure, their name, their purpose. Okay, so for example, just take an example, a delta wing aircraft would not necessarily possess a horizontal tail. So in aircraft having the what? Delta wing, it's not necessary that they will have the horizontal tail. Okay, they may have only that vertical tail and that delta wing. Although this is present in a canard configuration. So that's why if only that is there, if another configuration is used, that is called as the canard configuration, such as that of the Eurofighter Typhoon. Okay, so in Eurofighter, that Typhoon, they use the canard configuration. Each component has one or more specific function and must be designed to ensure that it can carry out these functions safely. Okay, so they must have their own specific function, and that function must be incorporated or done by those components only and with the safety. Now, next is load on the structural component. The structure of an aircraft is required to support two distinct classes of load. The first, termed as ground load, includes all load encountered by the aircraft during movement or transportation on the ground, such as taxiing and landing loads, towing and hoisting loads. So just see here, whatever in the aircraft element it's acting, that is structural elements, the same load almost you can see it's acting in the components also. Okay. So same, and ground load will be defined by same during the when aircraft is in movement on the ground or transportation on the ground, such as taxiing, landing, towing and hoisting. So these things, whatever the force will act, that as called as the ground load. Okay, so yeah, this S is not there. So second is air load. What that comprises loads imposed on the structure during flight by maneuvers and gusts. So during the flight, whatever the load that a load will experience by the flight, that is called as air load. And how that will experience the force? Because of maneuver, like moving up, okay, and because of the air gust. So whatever they will experience. So these two are the air loads. The two classes of load may be further divided into surface forces, which act upon the surface of the structure. So just see here, almost you can see it is similar to the element that from the previous videos. Okay, such as aerodynamic and hydrostatic pressure and body forces. So aerodynamic and hydrostatic pressure, and the next is the body forces, which act over the volume of the structure. So body force, okay, will act where? On the volume of the structure and are produced by gravitational and inertial effect. So this volume effect is there. Because of that, what happened? How that is affected? Because of the gravitational as well as the inertial effect. Basically, all air loads are the result of the pressure distribution over the surface of the skin. So what is the loads? Why that their loads is acting and from where that load came? So that load is because of the pressure distribution over the surface. So because of the pressure distribution, so it means you can say almost everything depends on the pressure distribution, how is there. Okay, so if like in wing also, if lift is there, or just here, okay, at the upper surface pressure should be less and at the bottom pressure should be more, and because of that only at the bottom part more pressure is there and at the upper surface less pressure is there, so it will start, more pressure will start pushing towards up, and that is only called that moving upwards. So over the surface of a skin produced by a steady flight, maneuver, gust and that gust condition. Okay. Now the function of a structural component. Generally these results causes what? Direct load, bending, shear and torsion. So in all parts of the structure, in addition to local normal pressure load imposed on the skin. So these four will act, and right, not only this force, in addition to that, what? That is a local, okay, normal pressure load imposed on the skin, means local pressure and normal pressure, whatever will be there, that also is acting on the aircraft. So means from here to here, this you can say the function and how that is getting operated the aircraft. Conventional aircraft usually consist of fuselage, wing and tailplane. Okay, so that conventional aircraft, whatever is there in that, these three things are there, which is fuselage, wings and tailplanes. The fuselage contains crew and payload. The later begin passenger, cargo, weapons plus fuel depending on the type of aircraft and its function. So what was first earlier, it was named as the fuselage contains crew and payload. Crew means pilot, air hostess and all that, those that pilot team, simply you can say. And payload, that can be what? Passenger, cargo or anything from which they can pay, or that's why it's named as payload, means through which that load will pay. Okay, or we will get the money because of that one, or that aircraft handling one. Okay. The fuselage contains, okay, the large one, cargo weapons. Okay, the wing provide the lift and the tail plane is the main contributor to directional control. The wings provide the lift. So just see the working. The wings provide lift. So lift is generated because of wing, and the tail plane is the main contributor to direction control surface. Right. So tail plane is what? Tail plane is the directional control. So tail plane is used for directional control, and wing is used for to lift. Okay. Now what about the this one? Fuselage. Fuselage will have the carrying, that means payload, to carry the payload. In addition, aileron, elevator and the rudder enables the pilot to maneuver the aircraft and maintain its stability in flying. In addition, so whatever these control surfaces there, other than that, earlier also I said that on the wings, aileron is there, elevator, these things are there. Okay, and the rudder enables the pilot to maneuver the aircraft and maintain its stability. So they can control these things from their cabin itself, the pilot cabin, and that can be stable. While wing flap provide the necessary increase of lift for takeoff and landing. Okay, figure shows typical aerodynamic forces resultant experienced by aircraft in a steady flight. Next is function of a structure components. The basic function of aircraft structure are to transmit and assist the applied load, to provide an aerodynamic shape, and to protect passenger payload system, and so forth from the environmental condition encountered in flight. These requirements in most aircraft results in thin shell structure where the outer surface or skin of the shell is usually supported by longitudinal stiffening member and the transferring frames to enable it is to resist bending. Okay, compressive and torsion load without buckling. Such structures are known as semi-monocoque, while the thin shell, which rely entirely on their skin for the capacity of resist loads, are referred to as monocoque. Okay, mono means one type of, and semi means just divided into two parts. First, we shall consider wing section, which, while performing the same function, can differ widely in their structural complexity. The wing of the small light passenger aircraft, though they are very small, one or two they can carry, but their wing is bigger than that one. The Havilland Canada Twin Otter comprises a relatively simple arrangement of two parts. Okay, of two sparse ribs, stringer and skin, while the wings of the higher consistence of numerous sparse rib and skin. However, no matter how complex the internal structure arrangement, the different component performs the same kind of function. Whatever is the complex internal structure that is not there, here the different component perform the same kind of function. The shape of the cross section is governed by aerodynamic axis. Yeah, no matter how complex the shape of the cross section is governed by the aerodynamic consideration and clearly must be maintained for all combination of load. This is one of the function of the rib. So function is controlling the rib. That rib is controlling the function entered into this one. They also activate the skin in resisting the distributed aerodynamic pressure. They distribute concentrated load, e.g. undercarriage and additional wing stored loads into into the structure and redistribute stress along some that around discontinuity such as undercarriage well, okay, inspection panel and fuel tanks in the wing area or wing surfaces. Ribs increases the column buckling stress of the longitudinal stiffness by providing and restraint and easily restraint and establishing their new idea. Okay, the stresses on longitudinal stiffness by providing and restraint and establishing their column length. A similar manner they increase as the plate buckling stress of the skin panel. Now next is load acting on airframe. The force on an aerodynamic surface, that is wing, vertical and horizontal tail, results from a differential pressure distribution caused by incidence, camber or a combination of both. So that can be caused because of the incidence, camber of a combination or both. Means camber as a combination and incidence, that one. Such a pressure distribution have vertical lift and horizontal drag resultant acting at a center of pressure. Okay, that will act as a center of pressure. In practice, lift and drag are measured perpendicular and parallel to the flight path respectively. Clearly, the position of center of pressure changes as the pressure distribution varies with speed or wing incidence. So once that center of pressure will change based on what speed and wing incidences. However, there is conveniently a point in the airfoil section about which the moment due to the lift and drag forces remains constant. So definitely when some point will be there through which if you will hold that one, then you can see that all the things are there. Okay. So we therefore replace the lift and drag forces acting at the CP by lifting and drag force acting at the aerodynamic center AC plus a constant moment m not as shown in figure. Actually, at high Mach number, the position of the AC, that is aerodynamic center, changes due to compressibility effect, while the chord-wise pressure distribution fixes the position of the resultant aerodynamic load in the wing cross section. The span-wise distribution locates its position in relation, say, to the wing root. Therefore, we see that tail planes and the fuselage are each subjected to direct bending, shear and torsional load and must be designed to withstand critical combination of these. Note that maneuver and gust do not introduce different loads but result only in changes of magnetic and position of the type of existing load. So where is the position of that one? Over and above these basics, in-flight load fuselage may be pressurized and thereby support hoop stress. Wings may carry weapon and extra fuel tank with resulting additional aerodynamic and body forces contributing to the existing bending, shear and torsion. While the thrust and weight of engine may affect either fuselage or wing, okay, depending on their relative position. So whatever the work you are doing, according to that you are getting the position. While the thrust and weight of the engine may affect either fuselage or wing, depending on their relative position. So whatever the relative position is there, according to that you have to just ground loads encountered in the landing and taxiing, such as the aircraft to concentrated shock log shock load, concentrated shock load, all through the undercarriage system, and the shock landing load produces a given shear maximum, minimum max bending moment and minimum bending moment plus torsion. Other loads include engine thrust on the wings or fuselage which act in the plane of symmetry, but may in the case of engine failure causes severe fuselage bending moment. Concentrated load shocks during a catapult launch and hydrodynamic pressure on the fuselage load on flanges or floats of spectacles. Okay, so this is again that a TGH Mixon is the book name. Okay, Butterworth Hillman. Okay, that is the 5th edition. So 5th, 8th, 2012, these many editions, editions are there. So just buy the latest one like 2020. Okay, so and you can refer. So just strictly quick all this one. So first our lecture topic was function of a structural component. Okay, and landing of airframe. After that, here I showed just how the structure will be there. Okay, so fuselage, the tailplane, and this one wings. Okay, in that many things are added. Then what we are seeing, depending upon their configuration, their name will be there for fighter aircraft, different configuration will be there for passenger aircraft, different condition will be there. Okay, so then we are seeing what loads on a structural component. What are the loads are there? So mainly one is there, right? Second air loads comprises load imposed on the structure during flight by maneuver and flight. During flight by maneuver and guts. The two classes of load may be further divided into surface forces which act during flight, maneuver, and guts. The two classes of load may be further divided into surface force which upon the surface of the structure such as aerodynamic and hydrostatic pressure, and the body forces which acts over the volume of the structure and are produced by gravitational and inertial effect. Basically, all air loads are the results of the pressure distribution over the surface of the skin produced by level flight or gust condition. Then we are seeing again what different that function of different components. So these are the components, how that will work, that we had seen in this one. Okay, so now the function is still again, let's continue. The basic function of an aircraft structure are to transmit and resist the applied load, to provide an aerodynamic shape, and to protect passenger, payload system, and so forth from the environment condition encountered in flight. So that is the basic function of the aircraft. These requirements in most aircraft result in thin shell structures where the outer surface, okay, or a skin of the shell is usually supported by longitudinal stiffening member and the transverse frame to enable resist. So these are some functions, okay, that is there for the structural component. Now the next is load acting on the aircraft. The forces on an aerodynamic surface, wing vertical or horizontal, tail. So all the pressure that results from a differential pressure distribution caused by incidence, camber, or a combination of both. Such a pressure distribution has vertical lift and horizontal drag. If horizontal drag is there, means thrust will be forward and lift will be upward. Such a pressure distribution of vertical lift, okay, horizontal over. In practice, lift and drag are measured perpendicular and parallel to the flight path respectively. Clearly, the position of the CP changes as the pressure distribution varies with the speed of writing speed, speed or wing incidence, not writing. However, there is conveniently a point in the airfoil section about which the movement due to the lift and drag forces sustained. Okay, drag forces remains constant. We therefore replace the lift and drag forces acting on the CP by lift and drag forces acting on the aerodynamic center plus a constant movement m naught as shown in figure. So these are there, just okay. Again, this is there how the pressurized cabin is there. Those things while moving up, the cabin is getting pressurized for passenger and some aircraft. Okay. So this is what the reference which you can refer for this topic.
Like, share and subscribe. Hit the bell icon for more updates.